Welcome everyone to the wonderful world of dun 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 math. Yep, that's right. Some of you might be going, oh, math. And some of you are super excited. And I'm excited to be doing this for you. And you might be thinking, hey, never done this before. That's right. This year we're going to be diving into math as deep as we can with some online tutorials. And then in class, I, your teacher, Mr. Nicanor, will try and help you and do my very best to help you understand the content in class. And whatever you don't finish, we would love for you to take your work home and try and understand the concept so that when we get to the summative assignments and summative assessments, you'll be doing your very, very best on those. Anyways, without further ado, let's get to math. Chapter 1, we're studying math patterns. And if you take a look at this page, this is the Chapter 1 opener. You guys ever been camping? I love camping. You're out by the fire, relaxing. You got the stars that you're sleeping under, and they're so big. It's just, yeah, love being in nature. How about you guys? You might have some memory camping with your family or with some friends as well. Well, one thing I don't like about camping is that you gotta pay sometimes when you go to campgrounds. Here's a picture of a campground. Actually, people going teepee camping, which is a lot of fun. If you want to take a look at the right side, right here, there's a question. How much would your class have to pay to go teepee camping? And you can see all the teepees all lined up over here. That looks like a lot of fun. How much should we pay? If we take a look at all the different prices, can you notice a pattern? I'm going to take a minute just to wait for you. Can you notice a pattern? We're going to call this our table of values. We've got a title right here, cost of teepee camping. We've got some values here, which are the number of campers. So if you have 4 campers, it's right there. If you have 5 campers, 6 and 7. And along the lines of this table of values, 4 campers would be paying $35 for one night. As you can see, the title is labeled cost for one night. If there are 6 campers camping, how much would it cost? Hopefully you said 55, because that would make you right. And 7 would be 65. What is the pattern that you notice here? Can you guys tell me? What is the pattern? If you said at 4 campers it starts at $35 and every camper after that is an additional $10, then you're right. Why don't we take a look at it here? Let me just zoom in. Just right that. I know it's a little bit blurry, but bear with me. All right, so if the pattern is 4 campers right here, and it's $35, and if you add 10 for every additional camper, that is the pattern. Now, if there was 26 students in our class, can you tell me how much that would cost all of us to camp? I'll give you a minute. Go ahead. Press pause, and when you have the answer, come back. All right, so what'd you guys come up with? Would love to hear it. Did you say 255? Awesome. It is actually and indeed $255. Look at that. Wow, that's a nice price. Now, there are many different ways that you probably came up with the answer. I want to know what different options that you did. I'm going to talk about 3 of them because with these patterns, we all look at math differently, and that's what I love about it. We can all come at from different angles, and then we can come up with the same answer. So, if you are someone, and bear with me, I'm just going to switch out my pen, and let's switch out the color. Let's do yellow. Actually, no, yellow won't come up. Let's do blue. Okay, some of you might have went 8, 9, 10, 11, and came up with all the different numbers. So 8 would be $75, 9 would be 85, and plus 10, Mr. Nicanor, come on now. And that would be 95, and that would be 105, and you would just keep going until you got to 26, and then you would get 255. Some of you might have actually saw it another way. Maybe you saw another pattern, seeing that the cost is actually $5 less than the total people times 10. So instead of saying 4, you could say 40 minus 5 would be 35. That's a pattern that you see. And you see, if you said that this was 70 minus 5, you end up with 65. So if you had 26 people, 260 minus 5, right, would actually be 255. Bravo. Way to see the patterns. And there might be another group of you who are mothletes who actually took another step and approach to it and took math to another level. Let's say that you understood that if we have 26 campers, 6 campers is $55. And you know that every extra student is an extra $10, right? So every extra student is $10. If we had 20 students at an extra $10, you multiplied $10 by 20 students, and you came up with $200. But that's just 20 students. That's where you add the extra 6. And what you did was $55 plus $200 is equal to, dun da da dun, I use that sound effect a lot, dun da da dun, $255. Well done. Great job. All right, so let's review what we're going to go through in this unit. You're going to be able to write a rule describing relationship between numbers in a table. So we just did table of values over here, and you'll be able to understand and give me examples by the end of this unit. You're also going to be able to use a ruler to create that table of values. You're going to be able to identify and create equivalent equations. We haven't got there yet. Don't get scared. And use number patterns to make predictions to solve problems. That's where we're going to go to. Awesome sauce. Let's next page this. Let's start at page 4. Chapter 1, Lesson 1. Let's do the examples together. The goal is to describe a number pattern within each column or row of table of values. I'm going to zoom in just a little bit. Here we go. So we see Leah here. She's playing a type of solitaire. You guys play solitaire? A lot of you know that I love cards and I have a lot of card stories. Won't bust them out now because we're doing math. Maybe I should do card stories in math. Okay, I can't get distracted. All right, so we have here Leah playing a type of solitaire. In each new row, she makes increases by the same number of cards. What this means is, every time she makes a new row, she's got a pattern that continues to add on to every row. Leah wants to continue this increasing pattern as far as she can with a deck of 52 cards. So how many rows can she get, and how many of each card is in each row after she's finished all 52 cards? Before we go on, can you see the pattern that she has in each row? I'll stop for a second, and why don't you take a look? Can you tell me the number pattern that she has for these rows? Press pause now until you figure it out. Awesome. Did you say 4? If you did, you're wrong. Sorry. It's actually 2. I won't do a lot of that. It's 2. If you count up the cards, let me get my pen right here. Let's try blue. We've got 1 card here. Then we've got 1, 2, 3, 3 cards here. Then we've got 5 cards here. And now we've got 7 cards here. If you take a look at the pattern, each row is increasing by how many numbers? You're adding 2 to each row. So let me get my pointer. 1 plus 2 is equal to 3. And by the definition of a pattern, it has to be consistent. So you're going to add 2 to each row. So let's try 3 plus 2 is equal to, 5. And 5 plus 2 equals 7. Now let's go back to this question. How many cards will be in the last row Leah can make? If you want to go ahead and solve that, press pause now and solve it. But what I'm going to do next is go through how she would solve it. So Leah created a table of values to find the card pattern. You might continue to ask, what are table of values? It's a way to present the numbers in columns and rows so that you can see the patterns. It's not just some scrap piece of paper where you're writing all these random lines. We saw with the TP camping that we had a table of rows on the left side. And also, table of values can be vertical or horizontal. And for example, Leah's tables are vertical because they're going up and down. Horizontal means that they go across. But these ones are going up and down. All right, so as we can see, she made 2 table of values. Let me bust out my pen. Let's do yellow. Why not? Mellow yellow. So let's circle table 1, just for me, and just so we know what we're working on. Table 1 has her row number, as you can see here, and then the number of cards in each row, which is what we did earlier. If we go back to over here, right? We were taking a look at the different rows, and we were numbering them off. And so she made a table just like that, just to organize her thoughts. Now, she's made a second table, and let's do green. Table 2 now has the same number of rows, as you can see here. It's the same number of rows, but she has the total number of cards used. Remember, she only has 52 cards, and she wants to know how many cards are going to be in the last row. Let's go back to that question right here. You see that? How many cards will be in the last row for Leia to make? All right, now that we know our goal, let's see if we can take some steps to slowly get there. All right, let's start with A. What is the pattern rule? What is the pattern rule for table 1? Can you take a second to take a look? Table 1 is right here. What is the pattern rule? Can you see that the pattern rule would be +2? What I mean by that is every time you add another row, you add 2 more cards. And take a look. Second row, you add 2, so 1 plus 2 is 3. 3 plus 2 is 5, and 5 plus 2 is 7. Perfect. Now let's take a look at question B. What is the pattern rule for each column in table 2? So here's table 2. Can you see a pattern in this? Why don't you press pause and take a look for yourself? There are a few different patterns that you could have named, but just to keep this video short, one pattern that I noticed is that the second column is the answer of multiplying the first column by itself. What do I mean by that? If you take this number in column 1 and multiply by itself, so 1 times 1, you're going to get 1. 2 times 2, you're going to get 5. Kidding. It's 4. 3 times 3 is 9. 4 times 4 is 16. So what I did was, or I didn't do anything, I just saw the pattern of taking the first column and multiplying it by itself, and you get the second column. That's a pretty cool pattern, huh? Next question. Question C. What numbers will Leia record in table 1 and table 2? So here's table 1, what's she going to record? And table 2, when she makes 2 more rows of cards. How do you know? Great question. So she's asking, let's see, let me zoom this in just a little bit so we can have a little bit more room to write. Let's get my handy dandy pen. Let's just do black. She's asking, according to this question, where is it? What numbers will Leia record? It's cutting off a little bit there. There we go. What numbers will she record in table 1 and table 2 when she makes 2 more rows of cards? And how do you know? I know because we know the pattern for table 1 is add 2. If I went 2 more rows, if I put 5 and I put 6, actually I don't like that color. Can we go back and do that again? Let me erase this bad boy. Sorry guys, you're going to notice that, don't do that. You're going to notice that I'm going to be making some mistakes, and mistakes are fine because there's always erasers. Just don't give up on me, all right? Perfect. Let's change our color to, let's say, green. Green. 5 and 6. We know that the pattern here is that we're adding 2. So if we went 7 plus 2, we would get, that's right, 9. We would have 9 cards in the 5th row. In the 6th row, how many would we have? 9 plus 2 would be 11. Perfect. We would have 11. Now let's go to table 2. We know that the pattern is multiplying it by itself. If we had row 5 and row 6, actually that color is way better than green. Let's go 5, and let's rewrite this because Mr. Nicanor wants to rewrite this. Okay. We multiply 5 by itself, and we would get 25 cards in total. And let's multiply 6 by itself, and what would that be? You're right, 36 cards in total. And that's how we know, because the pattern tells us so. So table 1, let's go back to table 1. Table 1 is we're adding 2, and table 2 is we're multiplying column 1 by itself. And that's how we know. And last question. If Leia has 52 cards in total, how many cards will be in her last row? How do you know? Let's figure this out together, shall we? All right, let's redo this. So 5, 6, we know that there's 25, and we know that in the 6th row, we have used 36 cards. We know that in the first column, 5, this would be 9, and 6, actually, let's do that again so that you're not confused. Here's 9, and in the 6th row, we would have 11. Now let's keep going, shall we? If we added another row in table 1, in our 7th row, we would have 13 cards in that row. We're getting pretty close to using all 52 cards. Can we make it in table 2? What's 7 times 7? You're right. Woo! 49. Wow. In the 7th row, we've got 13 cards. We've used 49 cards. How many cards do we have left to get 52? That's right, 3. If we made an 8th column, we would not have 13 plus 2. It wouldn't be 13 plus 2, which is 15. We would actually have 3 cards. That would break this pattern. So we can't count the 8th row. If we did 8 times 8, which would be 64, that pattern would still go, but 64, we don't have 64 cards, we only have 52. So we can't have that column. The answer would then be, in the 7th row, which is the final row, there would be 13 cards in that row because we've used 49. There's 3 extra, that's right, but having a pattern of 13 wouldn't work because we wouldn't have 13 here. Or sorry, 15, just like what we're doing here. All right, sorry, got a little messy at the end. Let's clear that up just a little bit. Hopefully that helped you out with the math. If you didn't understand certain parts of it, I encourage you just to stop this and rewind and maybe have a scrap piece of paper and just do it along with me, or press pause every now and then to help you understand it just a little bit more. I'm looking forward to seeing you in class tomorrow. Be prepared for a little check-in to see if you watch this video or how much you understand of this concept, and we're going to run and do some math in that class tomorrow. All right. Welcome and congratulations to finishing your first online course. Awesome sauce! See you tomorrow. Bye.